In this video, we're going to look at two examples on how to solve right triangles. So there's a few things that you need to remember. First of all, you can rely on Pythagorean's theorem to solve for missing sides. And second, you can rely on the fact that the sum of angles is 180 degrees to find missing angles. So you're going to see this problem in two ways. The first way, you're actually given the triangle with some pieces labeled inside. The second way is you're just simply given the pieces. So let's look at this first example here where we give you the triangle. And notice we went ahead and labeled the triangle. Now, one thing that we know based on this example is that these are going to be right triangles. So you can label this if you want. But what that also means is that S is 90 degrees. Now, in order to find angle T, one of the things that we know is that we can take my 180, subtract out the 90, and subtract out 26.7 degrees. In doing that, that's going to give you the leftover. So here you're going to find out that angle T is 63.3 degrees. Now the reason we round to one decimal place here is because if you look at the degree that's given, you've rounded to one decimal place. You want to make sure that your problem has uniformity, and so if your angle rounds to the tenths, then you need to make sure your other angle does too. Now the other thing we have here is we have two missing sides, so we can't use Pythagorean's theorem yet. So instead, one of the things that we use is we would use our trig functions. So we have angle, or T, and we also have R. Now if you look, angle R was given and the side length ST was given. So I would try and use as many given pieces of information as I can. So here, in order to find S, we'd use angle R, and S would be opposite over hypotenuse. So in this case, we would have the sine of 26.7 degrees is equal to 0.17 divided by S. So here we would have S equals 0.17 divided by the sine of 26.7 degrees. You would use, say, a graphing calculator, kind of like this one, and we would go ahead and enter this as is. So 0.17 divided by the sine of 26.7, hit enter, and we get that S is equal to 0.38. Now again, we rounded two decimal places because the given number was rounded to two decimal places, so we want to make sure that it matches. Now after that, we have to find T. So we're going to use the same thing. We're going to use the two pieces of given information to find the missing side. So here, adjacent is missing, but we have opposite. So we would do the tangent of 26.7 is equal to 0.17 divided by T. In this case, T is going to be 0.17 divided by the tangent of 26.7, and this is going to give us our result. Just like with the other, we would take our calculator, 0.17 divided by the tangent of 26.7 degrees, hit enter, and there we go. So this would be 0.34. Now since I have found the other three missing pieces, as well as the fact that we already know that angle S is equal to 90, we have solved our triangle. Now here we are given two sides. So with this one of the things that we would do with it is we would go ahead and draw your triangle. So whenever a triangle is not given, I would highly recommend drawing it yourself, and then you need to label it. So we have A, we have B, and we have C. We know that angle C has to be 90 degrees. We know that side A is 12.5, and we know side B is 18.3, and the hypotenuse is missing. In this case, because we have two sides, we would use Pythagorean's theorem. A squared plus B squared equals C squared. So 12.5 squared plus 18.3 squared equals C squared. When you solve, you'll end up with C being 22.2. Again, we round to 1 decimal place because that's what's been given. Now we need to be able to find our angles, and we're going to approach this in the same way that we did our first triangle. And so in this case, however, we would be looking at the angle as being the missing piece. So here we have opposite over adjacent. So we would have the sine of A is equal to opposite, sorry, not sine, tangent. The tangent of A is equal to opposite, so 12.5 over the adjacent 18.3. So in order to find A would be the inverse tangent of 12.5 over 18.3, and that is going to give you A. So in this case, we should end up with 34.3 degrees. Now, the way that we get that is to take your graphing calculator Okay, so we're going to take your graphing calculator, and we need to do the inverse, so we're going to go second of tangent, so notice that gives me my inverse, and we're going to input 12.5 divided by 18.3, and here we got your 34.3 degrees. The last piece we need to do is we need to find B. So again, we have opposite over adjacent, so we're going to do the tangent of B is equal to 18.3 over 12.5. So B is going to be the inverse tangent of 18.3 over 12.5. So this is going to be, again, enter or use your calculator, second tan of 18.3 divided by 12.5, hit enter, and we get 55.7 degrees. Now, one of the things that you can do with a triangle like this when you don't have any angles is you could then take your angles and you could take the two that you calculated plus the one we assume, add them all together, and you should come up with 180 degrees. And you can use that as your check to make sure that you did it right. Alright, so there are two different examples about how to solve right triangles based on information that's been given. So I do hope you enjoyed this short video. If you have any questions, please don't hesitate to let me know. Otherwise, I look forward to seeing you next time.